Okay, so I'm going to explain dipole moment. So dipole moment, I'm going to explain quite complex molecule. The type of molecule like AB1, AB2, AB3, AB4, AB5 and AB6. So AB1 means two atoms or two groups, and AB4, AB3 means four atoms or four groups, right? So first of all, let's consider AB1. That means this is diatomic molecule, right? Diatomic molecules. So for example, this is hydrochloric acid, HCl, and this is the bonding electron between hydrogen and chlorine, right? So if you look at the electronegativity chart, this is chlorine, it has electronegativity 3, and this is hydrogen, it's 2.1, right? So 2.1, so electronegativity difference between these two atoms is 1.9, right? So 1.9, so that means chlorine is stronger than hydrogen, right? So most of the time the bonding electron will spin towards the chloride side, right? Chloride side. So because of this, so chloride will be minus negative, delta negative, and hydrogen will be delta positive. And so one pole is positive, another pole is negative. So because of this molecule will be polar. So polar means dipole moment mu not zero. On the other hand, homodiatomic molecules like hydrogen, oxygen, fluorine, chlorine, nitrogen, bromine, so any diatomic molecules, if you look at here, this hydrogen and this hydrogen, they are equivalent. So the bonding electron will be equally shared, right? The bonding electrons will spend their time equally to both atoms. So that means there is no difference in the electronegativity, and so the dipole moment is zero, right? Dipole moment is zero. In the same way, oxygen, fluorine, chlorine, nitrogen, they are homodiatomic, so they do not have any electronegativity difference, and because of this dipole moment is zero and they are non-polar. Okay, so now come to the triatomic molecules, AB3, right? AB3 triatomic molecules. So for example, carbon dioxide, sulfur dioxide and water, right? I have also placed here as AB2 class. I will explain why. Okay, so at first consider carbon dioxide. So if you count the number of electrons, carbon has 4 in the outer shell and oxygen has 6, so 2 oxygen, total 16. Total 16, 16 is the multiple of 8, so 8 times 2 is 16, so there is no lone pair on the central atom. So this is the structure of carbon dioxide. This is 4, this is for carbon 8, and this is 4, this is 4. So total 16 electrons, and oxygen is more electronegative than carbon, so oxygen will pull the bonding electron towards oxygen from carbon. So one of the dipole will go this way and another dipole will go on the opposite way, and because of this they will cancel each other, right? They will cancel each other and dipole moment will be zero. So zero dipole moment means they are non-polar. This one is non-polar. So now sulfur dioxide, if you see, sulfur has 6 and oxygen also has 6 electrons on the outer shell, 2 oxygen, 6 times 2, total 18. So the highest multiple of 8 is 16. So you have 2 extra electron. This is 2 lone pair electron. So it's going to be on the sulfur. So if sulfur dioxide looks like carbon dioxide, okay. However, because of this lone pair electron will push on the bonding electron. Okay, so because of this, the sulfur dioxide will be a bent structure. Bent structure, right? Bent structure. So oxygen is more electronegative than sulfur, so oxygen will pull the bonding electrons, or bonding electrons will spend most of the time to oxygen. So one of the dipole will be here, there, and then resultant dipole will be this way, right? So here dipole moment is not zero, so this is why sulfur dioxide is polar. So now if you go to hydrogen dioxide, dihydrogen oxide, that means water. So you have two and two lone pair. So this lone pair will push to the bonding electrons, okay, making the water molecule bend. So sorry, this is wrong. So oxygen is more electronegative, so oxygen will pull from hydrogen, okay, and the resultant dipole will be this way. So this way, so here water is, dipole moment is not zero, so this is polar. So methanol, this is, if you look at here, this one is a group. This one is a group. So if you look at here, this is oxygen, this is hydrogen, right? And this is a group, methyl group, right? So it is also a sort of AB2 class again. So, but different. So look, if you have bonding pair here, right? So carbon is more electronegative than hydrogen, so carbon will pull bonding electrons. Dipole moment will be this way, from hydrogen towards carbon, and carbons towards oxygen, hydrogens towards oxygen, and the net dipole will be this way. So this one is also polar. Ethanol is same. This is, now you have to consider this one as a whole group. This one is a whole group. So oxygen will pull from hydrogen, okay, and this is, you have lone pair. Because of this, you will have dipole moment this way. This is dipole moment not zero. This is also polar. Okay, so now AB3 class, for example, sulfur dioxide and nitrogen dioxide, negative, right? So here if you count the number of electrons, this is 6, and 6 times 3, 12, 24. 24 is the multiple of 8, so there is no lone pair here. So if you, okay, so this is sulfur dioxide, but if you here, see here, this side is crowded, but you have nothing here. So because of this bond will push on this bond and this bond, so it will be a trigonal molecule. So one of the dipole will be this way, because oxygen is more electronegative, another one is this way. The resultant dipole of this two is this way, right? And this one is opposite, so they will cancel each other. So dipole moment is 0, this is non-polar. On the other hand, in case of nitrogen is 5, 6 times 3 plus 1, this is negative, you have total 24. So if you do this structure, the structure will be like this. If you count, so here you have 8 electrons, right? 8 electrons, here you have 8 electrons, right? So 8 electrons, but you have here, this is double bond. So because of this extra electron, sometimes double bond will be formed here, okay? And if it happens, this bond will be broken. So now this one has 8, this one has, double bond is here, and the negative charge is outside the bracket, okay? So in another rotation, you see this guy will form another bond, and this bond will be released, right? So ultimately, so every oxygen will have a single bond in nitrogen, and all of the oxygen will have partial double bond. Partial double bond, and this arrangement is also trigonal planar. So one of the dipole will be this way, another one this way, another one is this way, right? So the resultant dipole of these two is this way, which is opposite of this way, right? So they will cancel each other, so dipole moment will be 0. That means this is non-polar. Okay, so now AB4. AB4, the most famous molecule is methane, right? Methane, this is natural gas, and we know this is tetrahedral. So tetrahedral, hydrogen is, carbon is more electronegative, so carbon will pull electron towards it, right? And this is 109, all of the angle 109.5, so they will cancel each other, okay? So this one will cancel, maybe this one, so all of them will cancel each other, so the dipole moment is 0. On the other hand, here if you see these three is pulling in the same direction, but chlorine is more electronegative than carbon, so chlorine will pull here this way, and because of this they are all going almost same direction, so dipole moment is not 0. This is a polar molecule, okay? Now AB5, like phosphorus pentachloride. Phosphorus, you have 5 electrons in the outer shell. Chlorine, it has 7, so 5 chlorine. 35 plus 5, 40. This is multiple of 8. There is no lone pair, and this is trigonal bipyramidal. And if you look at here, so this is the structure, right? This is the structure of phosphorus pentachloride. So one of the chlorine is more electronegative than phosphorus. It will pull electron. Dipole moment will be this way and this way, right? This way. And the resultant dipole will be this way. So this one will cancel this one, and this one will cancel this one, right? So the net dipole will be 0, and the molecule will be non-polar, okay? So now sulfur tetrafluoride. Sulfur has 6 electrons on the outer shell, and fluorine has 7. 7 times 4, 28 plus 6 is 34. So the highest multiple of 8 is 32. You have 2 lone pair. Okay, 1 lone pair. 2 electrons, 1 lone pair. Okay. So this is sulfur, and this is the lone pair electron, like this. And this is one fluorine here, another one is here. If you look at here, so this fluorine will pull electron from sulfur because fluorine is more electronegative. Okay, they will pull this way, and this one will cancel this one, right? And here you have the, both of them are pulling in the same direction. They have the resultant dipole. So here dipole moment is not 0, so this one is polar molecule. So bromine trifluoride, here you have bromine, you have 7. Fluorine also have 7 times 3, total 28. So highest multiple of 8 is 24, so you have 4 extra electrons. That means you have this 4. This is lone pair. So this lone pair, we have 2 lone pair. 2 lone pair. So this is bromine. The structure is like this. So this one is pulling, and this one they're pulling in opposite direction, so they will cancel. But here you have nothing to cancel, right? So because of this, mu dipole moment is not 0. That means this one is polar. Now xenon difluoride. Xenon, it has 8 electrons on the outer shell, and fluorine has 7 times 2, 22 total. Highest multiple of 8 is 16. So you have 6 electrons on the central atom which is not bonded, okay? So that means you have 3 lone pair. So one of the fluorine is pulling this way, another fluorine is pulling this way. So this one and this one, they will cancel each other. So you are going to have dipole moment 0. That means this one is non-polar. And now finally AB6. AB6 like sulfur hexafluoride and bromine pentafluoride. Okay. So now if you look at it, this is 6, sulfur has 6 electrons, fluorine has 7 times 6, total 48. 48 is multiple of 8, so there is no lone pair on the central atom. So this is sulfur, this is octahedral, and all of them are pulling in opposite direction. So they will cancel each other. This one will cancel this one will cancel this one, and this one will cancel this one, right? So ultimately you are going to have 0 dipole. This is non-polar. Bromine pentafluoride. Okay. So if you look at here, you have 7 electrons on bromine and 7 also fluorine, 5 fluorine, 7 times 5, 35, plus 7, 42. Highest multiple of 8 is 40, so you have 2 extra electrons. This is your lone pair, right? On the central atom. And this is the structure. This one will cancel, this one will cancel, and this one will cancel this one, but you do not have anything to cancel this one, right? So because of this, the dipole moment is not 0, so molecule is going to be dipolar. And thank you so much. Thanks for watching. I hope you enjoyed it. Thank you so much.